Here we'll be looking at the basic curves of the sixth trigonometric function. Initially we are looking at the sketch of the sine and cosine function. The graph of the sine function is called a sine curve, and the graph of the cosine function is called a cosine curve. First, let's look at the sine function. Y is equal to sine x. Just like any function, we can choose arbitrary values for x and get a corresponding value for y. So here I've chosen x is equal to 0, pi over 6, pi over 4, pi over 3, pi over 2, and pi. We know the sine of 0 is equal to 0, the sine of pi over 6 is equal to 1/2, pi over 4 is equal to square root of 2 over 2, pi over 3 is equal to square root of 3 over 2, the pi over 2 is equal to 1, and the sine of pi is equal to 0. If we plot these corresponding points on our rectangular coordinate system, where our x-axis is represented by our angle, and here we have our y values, we see that we have the point 0, 0, pi over 6 will give us 1/2, square root of 2 over 2 will give us this corresponding point, square root of pi over 3, this corresponding point, and when it's pi over 2, we have this point here, which is our maximum value. And we can continue filling in all the points along, but this is what our basic sine function or sine curve will look like. The point for one complete cycle of our sine curve is known as a period, and our period goes from 0 to 2 pi for the basic sine function. The amplitude is half the distance between the maximum and minimum point. So here's our amplitude, here's our maximum minimum point, the amplitude is half that distance, so the amplitude for the basic function would be 1. The range is our corresponding y value. We can see from this that the range of our sine function is from -1 to 1. So our range will never be below -1 or above +1. Our sine function is symmetrical around the origin. So, and we know this is basically an odd function. Now let's look at the cosine function. We can use an identical procedure to sketch our cosine function. Here we have our cosine function, y is equal to cosine x. The curve from our cosine function will give us our cosine curve. We are going to choose values for x, which will result in a corresponding value for y. We know that the cosine of 0 is 1, so when we substitute 0 here, y is equal to the cosine of 0. Cosine of pi over 6 would be square root of 3 over 2. The cosine of pi over 4 is the square root of 2 over 2. The cosine of pi over 3 is equal to 1/2. And the cosine of pi over 2 is equal to 0. Cosine of pi is equal to -1. If we plot our corresponding points on our coordinate system, here our x-axis is represented using our degrees. For 0, we have 1. Pi over 6, we have the square root of 3 over 2. Pi over 4, we have square root of 2 over 2. For pi over 3, we have 1/2. And when we have pi over 2, it's 0. And for pi, we have -1. So here we can see that the maximum for our cosine function is 1, and the minimum is -1. So our range for cosine is from -1 to 1. The period is 2 pi. The time it goes from a maximum point to a maximum point, that's 1 cycle, and it's represented here in green. The amplitude is similar to the sine function in that it's half the distance between a maximum and a minimum point. So the distance between a maximum and minimum point is 2, so our amplitude here would be 1. In sketching our sine and cosine curve, it's very important to know what our maximum and minimum points are, and also what our intercepts are. Similarly, the period and amplitude will play an important part in sketching this curve. Now let's look at a few examples. Before we graph our sine and cosine curves, let's look at our general equation for our sine and cosine function. Here we have for the sine function, y is equal to d plus a times sine b x minus c. And for cosine, we have y is equal to d plus a times cosine bx minus c. In both functions, a represents the amplitude. If you recall, we said the amplitude was half the distance from the maximum to the minimum point. So a is the absolute value of a is our amplitude. For a standard sine curve or cosine curve, our amplitude is 1. When a is greater than 1, we have a vertical stretch of our sine and cosine function. That means it's going to expand in this direction. When a is less than 1, our standard curve will shrink. It will get smaller. The period for a standard function, the period would be 2 pi. In general, if there's a coefficient in front of the x, we divide by 2 pi by b to get our horizontal stretch or shrink. So if b is less than 1, the graph will generally stretch out. And if b is greater than 1, our period will be reduced. D in both function is our vertical shift, so it will either shift our entire graph up or down. To determine the left endpoint and the right endpoint of our sine or cosine function, we set the inside bx minus c equal to 0 and bx minus c equal to 2 pi to determine the left endpoint and the right endpoint. Now we will look at some examples using all these tools to sketch our sine and cosine curves. In these two examples, we're going to find the period and the amplitude of these two cosine functions. Here we're given both the graph and the function itself. We can see from the graph that our period, the maximum point on our graph is 3 and the minimum point is -3. So the total distance is 6. We know therefore that our amplitude is half this distance, which should be 3. We also know from the standard form or the general form of the cosine function that this number, the coefficient of the cosine, is always the amplitude. So we can tell from the equation or from the graph. The period is from one peak to the next. So here, from here to here, would be our period for this graph. It goes from -pi/2 to pi/2. So that's pi/2 twice. So our period here would be pi. An alternative method of finding the period, once again, would be to divide 2 pi over the coefficient of the x. So 2 pi over 2 would be equal to, once again, pi. So remember, this is our b, and our period is equal to 2 pi over b. So we can either look at the graph or we can use the formula to find the period. Here we're only given the equation. So we know the coefficient of the cosine is our a, so our amplitude is 5/2. The period, we don't have the graph, so we have to use our formula. We know b is equal to 2, the period is equal to 2 pi over b. Or b in this problem would be 1/4, since this is 1/4 x. So this becomes 2 pi over 1/4, or 2 pi times 4/1. So our period would be 8 pi. So you can see that for this graph, it's stretched, the entire period is 4 times the original amount, so it's now 8 pi at an amplitude of 5/2. Here we're going to describe the relationship between two graphs, the graphs of f and g, and we will be looking at the amplitude, the period, and the shift to compare them. First, we'll look at f of x is equal to cosine x, and g of x is equal to cosine of x plus pi. For both these functions, our amplitude is 1. So here the amplitudes are the same. Our period are also the same, since our coefficient of x is 1. Our period would be 2 pi over 1, so our period for both of these is also 2 pi. And the second one, g of x, we realize it's now x plus pi. Whatever is inside the parentheses is a horizontal shift. And we can determine our horizontal shift by setting this equal to 0 on 2 pi and solve it. So our shift would be x plus pi equal to 0. So minus an pi from both sides. X is equal to negative pi. So we realize that this graph here, g of x, is shifted pi units to the left. So it's basically the same thing as the f of x function, except it's shifted pi units to the left. Here we have f of x is equal to the cosine of 4x, and g of x is equal to negative 2 plus the cosine of 4x. Once again, the coefficient of the cosine is 1, so our amplitude is equal to 1. Our period would be equal to 2 pi over b. Here our b is 4, so this is 2 pi over 4, so this would be pi over 2. So this is an extremely narrow graph. So it's going from a period of 2 pi to just being pi over 2. Our shift. This has no horizontal shift since we don't have our bx term inside the parentheses. However, we do have this negative 2 off to the side, which represents our d in the general form. So this is our vertical shift. So this is a vertical shift. And here it's being shifted downwards 2 units.